C.2, questions of quiz 2. First question, is the bubble sort an in-place algorithm? First, you need to know the definition of in-place algorithm. The extra storage space, okay? Extra means excluding input-output data. So you need some storage space for input-output data, but other than that, you may need more storage space. So the extra storage space should be bounded by constant. Okay? Space bounded by constant. Okay? Yeah. All right. So let's check. Here, the bubble sort. We do local swap. The basic operation local swap. So let's assume when we do swap for two adjacent elements, okay? When we do that, we just need one extra storage space, okay? Yeah, so one extra storage space. So you copy one element here, then copy element, then copy back. Okay. So that means one variable is enough to complete one swap operation. So you do this everywhere in the array. So the extra storage space you use this part. Yeah. Okay. One variable, right? Yeah, one variable. Yeah. But if you look at other places, for loop, anyway, if you look at all the possible places you use the extra storage space, there is no question bounded by a constant. Yeah, so that's the question 1. All right. Question 2. All right. When we solve the element uniqueness problem, is it acceptable to sort the array first? Sort the array first. Is it acceptable? Yeah. In the notes, we learned 2 algorithms. One, we do not sort it. We just find the answer directly. The second, we sort it. After we do the comparison, we find if we sort it first, we get a better performance. Okay? Yeah. So based on that, so we think, we can make this answer. It is acceptable. Yeah. But here, I want to point it out later when we learn new technologies. All right? Later, we will learn another much faster searching algorithm called hashing. After we learn the hashing technology, we can do faster than the sorting way. Sorting, data preparation way. Yeah. But after we learn the hashing, yeah. Even when we use hashing, we can do faster. Yeah, but this method, the overhead part is high. You need to prepare your data structure hash table. Yeah, so that part, so the overhead part, you need to pay some cost. Yeah. Other than that, overall performance, no question, much faster. Yeah. But sometimes when people solve real-world problems like this, because of the overhead part, sometimes people still try to avoid using that. Yeah. If you do not use the hashing, then that is the next best solution. Hashing is the best solution. This is the second best solution. Yeah. All right. Question number 3. Given an array of integers with n elements, we want to find both the maximum and the minimum. What is the growth function of the algorithm? So this question, based on my experience before, many students miss this. So when I give the question before, I didn't give the both maximum minimum. I only give one, so maximum. Still, large number of students miss that. Missing part is at the growth function, the meaning of the growth function. Okay, growth function, we ignore the minor terms, and we also ignore the coefficient of the dominant term. So I want you to know the meaning of that. Yeah. Otherwise, then you may get a wrong answer. Okay, so here, let me tell you the correct answer. Correct answer is n. Growth function is n. All right. Then let's look on it. Look at the solution. Yeah. All right, so this is the array with n elements. Yeah. The first time you try to find the maximum, right? Yeah. The first time you try to find the maximum. Based on our module 1 part B, find the minimum element. Based on the solution there, you need n minus 1 comparisons. All right. After that, you take away that maximum, because that maximum cannot be the minimum, right? Yeah. You assume that maximum cannot be the minimum, right? So the next round, you want to find a minimum, but this time you have n minus 1 elements. In the n minus 1 elements, you try to find the minimum, the number of comparisons n minus 2, right? Yeah. All right. Adding together, you may get the total number of comparison 2n minus 3. All right. Yeah. But that's the answer, right? Yeah. Now, in order to put the answer there, the growth function, first, you ignore the minor term. You only keep the dominant term 2n. All right, so then 2n, you don't need the coefficient 2. Growth function, we never include, we never include the constant coefficient. Yeah. So that is n. So that's the answer. All right. Yeah. So some of it, if you put a 2n, not correct. 2n minus 1, 2, 3, whatever, not correct. Okay. Yeah. Another thing is, yeah, here, I just want to make comments. This way, it looks natural way, but it is not the best way. The best way we can do faster than that. Faster than that. The reason is when you find maximum, you make many comparisons. Then when you find a minimum, you can use that the information that you have used before here. So you can save some of the comparisons if you can use information in the first round. Okay, yeah. But how to, a little tricky, yeah. So here I don't want to talk about that. A little tricky, the answer approximately 3/2. Yeah, approximately, yeah, plus minus 1, yeah. There is some small number, plus minus, yeah. So approximately this number, the best solution, yeah. All right, so if I have chance, I can talk about the solution of this, yeah. But here, I didn't ask you for the best solution. So even you do not use the best solution, you can still give the correct answer here. Now, question 4, when we compare the growth functions of two algorithms, if the limit of the ratio of these two functions does not exist, do we still have a chance to find which one faster? Yes. In notes, I explain. I give you counterexample. So counterexample on that special example. Okay? Yeah. So the example is not in the notes. If you didn't watch the video, so you may not get it. Yeah. So here I just give it to you another time. For example, may not be exactly, but similar. Okay. Yeah. For example, n squared plus 1. Okay. One function is like this. Okay. One function is like this. Another function is like this. Minus 1. Okay? Yeah. Okay? So these two functions, there is no limit, right? No limit. Yeah. The limit of the ratio, limit of the ratio of these two functions does not exist. But we have chance to find which one faster. Here, same. We use inequalities. So we can still, find which one faster, which one slower. Yeah. So in this case, same growth function. Yeah. After we remove constant part, minor term, both n squared. Yeah. All right. An array with 6 elements sorted in descending order. How many inversions? Check your understanding of the inversion concept are there in this array. Yeah. So let's assume descending order, right? Yeah. But you need to know the meaning of inversion. Okay? Yeah. 6, 5, 1 inversion. Because the order, reversed order, the ordered way, 5, 6, right? 5 appears before 6. Yeah, that's the ordered way. Now, not the ordered way, so we count as an inversion. Yeah. All right. When we use 6 to compare the number of inversions, yeah, we start with 6. 6, 5, 6, 4, 6, 3, 6, 2, 6, 1. Okay? Yeah, start with 6, we have 5 inversions. Start with 5, 1, 2, 3, 4. All right? 4 inversions. Then 4, 3. So you can see 3, 2, 1. Okay? Adding together, you get 15. Yeah, 15. That's the answer. Okay? That's the way we find the number of inversions. Okay? Yeah. All right. Number 6. We have an array with more than 2 elements. In place concept. All right. Yeah. If it is not sorted, here we assume it is not sorted, the array. Under that assumption, there must be at least two elements that are not in place. Answer is true. At least, so the elements that are not sorted greater or equal to 2. It is true. Why it is true? So you try to disprove it. You cannot disprove it. Okay? So how do we disprove it? We use contrapositive, right? Contrapositive method to disprove it. Yeah. We assume it is false. Yeah. Suppose this is false. Okay, if we assume it is false, then that means less than 2, right? Yeah. Less than 2. Less than 2, but not sorted. Remember, it's not sorted, so it cannot be 0. Okay, the number of elements that are not in place cannot be 0. It's 0, it is sorted, right? So less than 2, greater than 0. So then the number of elements that is not in place, only 1. 1 element not in place. The remaining n-1 elements are in place. Is it possible? In an array, you have n-1 elements in place, right? Then the remaining last element has to be in place. Because n-1 already occupy their correct positions. Then the last one, that's the only position you can take, and that is your right position. It cannot be wrong. It must be in place. So in that way, this case cannot happen. Okay? This case cannot happen. So that's why if we use the contrapositive method, we cannot disprove it. It must be true. Yeah. All right. Number 7. When we apply the brute force string matching, this one I changed the first version from n to k. Because in my mind, I just want to ask you that unknown variable. What is the value of that? But when I write there, I use k, but I put n there. So that caused a lot of confusion. Later I fix it. So I hope so you didn't, get a wrong answer due to this confusion. All right. To solve it, very easy, right? N equals 40 in our formula. So the length of the text 40. Our formula n minus m plus 1 equals 24. Although here we use k, but the same. 40 minus k plus 1 equals 24. So you solve it for k equals 17. So that's the answer, 17. All right. Number 8. A travel agency tours 5 cities. How many tours are containing all of these cities? Our brute force, the traveling salesman problem, and n factorial. Remember the answer there, n factorial. This many different tours. Here, 5 factorial. 5 factorial equals 120. So the answer is 120. But if you put 5 factorial, also correct. So in my answer options, I have that 5 factorial. So you should be okay putting 5 factorial. All right. Number 9. Pythagorean theorem, the distance, line distance between 2 points, giving you coordinates of those 2 points. You just do the calculation using the formula. The distance between x coordinates 6 minus 13 square, distance 12 minus 36 square. Okay, yeah. So you can simplify it. 7 square plus 24 square, square root 25. Okay. Very straightforward. Yeah. You can use calculator. You can use Wolfram Alpha. Yeah, I recommend that website. Wolfram Alpha. Yeah, for a situation like this, yeah, you can use all those tools to find your answer. Yeah. Here, when I make questions, I try to make good number for you. Yeah, so not many decimal point positions, that kind of number. Yeah. All right. Last question. Last one. Number 10. When we apply the brute force string matching find 18 character pattern, yeah, this many total characters, how many character comparisons do we need for average case? We have that formula, right? Yeah, we have that formula, okay? The best average case, the best case 1, the worst case 184 minus 18 plus 1. Average case plus divided by 2. Best plus the worst divided by 2. For this case, it is correct. Okay? For binary search, it's not correct. Okay? In our binary search, the best case 1, the worst case some number. If you need to find the average case, you cannot just add those 2 divided by 2. It's wrong. Okay? So you need to do some analysis. Yeah. But here it is correct because all the intermediate cases, they have the same chances. Yeah. So that's why we can use this formula, then multiply 18, right? 18 characters. Yeah. Because every time you need to do this many character comparisons. Okay. All right. So then you do the calculation. Yeah. Because here you have to put a number there. Here I didn't enter formula there. Yeah. So you have to put a number here. Yeah. So my calculation is this many. Yeah. This many. Yeah. All right. Yeah. Hope it's correct, right? Yeah. We can do calculation a little bit. Yeah. 1A6 minus 18, 8, 6, 1, right? 18 over 2, 9, 8, 2, 7, right? Yeah. 4, right? Yeah. 1, 5, right? Yeah. Yeah. Sorry. Yeah. Yeah, because 6. Yeah. 54 plus 7, 60. Yeah, so we carry 6. 1, yeah. So yeah. Yeah, that's the number. You can use a calculator or use the Wolfram Alpha here. Yeah. It's okay. Yeah, but sometimes we just do it on scratch paper if you like it. Okay. Yeah. Anyway, all right. So that's all questions of quiz 1. Yeah. So let me stop this. Oh, quiz 2. Yeah, sorry. Yeah, quiz 2. Yeah. After this one, I will explain 8 questions. Yeah. In our homework, 25 questions, I select 8 relatively hard questions. So I will talk about in C.3, and C.4. 4 questions each part. Yeah. All right. Yeah.